This is code.org. Let's see what we're doing. Consider the following. Private int data. Precondition. So this is our instant variable right up here. It's an array of data. Data contains no duplicate elements, and the elements are in ascending order. Ooh, okay. So we have a method mystery. We're going to pass it a low, a high, and an int, which is, or well, they're all ints, a number. Okay. And then we're going to find midpoint. It looks like we're adding the low and high numbers together and dividing by 2. Interesting. And what is occurring here? Well, if the low number is greater than the high number, then we return low. Okay? So else, if the data at the midpoint, so whatever number is at the midpoint, is less than number, so if it is less than the number, what do we return? We return the number plus 1. Okay, so if our data at the midpoint's less than the number, we return, this is recursive, we call our method again, except we don't want the data apparently that is less than our number. So mid plus 1, which means low and high must be indexes, because that's how they're using mid right here, and mid is coming from low and high. So we're pushing up the index by 1. So no longer is the low point, the low, whatever it used to be, it's our midpoint plus 1. So we're eliminating everything that is less than num. Num must be our target value. High and then num. Else, if data at mid, so the number at the midpoint is greater than our number, then our low, oh, yep, this makes sense. Our low value stays the same. We change our high value to the mid minus 1 because it's greater than our number and number. So it seems like we're going to end up returning either low is going to be greater and we'll return low, or we'll be returning the midpoint. The midpoint would be, this would only get returned if the data at the middle is equal to our number. And then this will get returned when the low, int low, is greater than high. And so if low is greater than the high, if the low index is greater than the high index, that means that the value before was just greater than our current value. So it must have dropped below right here, and the low we must already know at that point is going to be less than our index. Now the low could be 0 because maybe nothing is less than our value we passed it. But regardless, if it is 0, it would still be telling us there are no numbers more than what we have. So the number of elements in the data set that are less than the number, that sounds possibly right. The number of elements in data that are less than or equal to the number. No, this doesn't care about equal. Notice less than and less than. The number of elements in the data that are equal to the number, no equal here. The number of elements in the data that are greater, definitely not. We're looking for low. The index of the middle element. Boom and boom. Cool. Make sure you go back through this carefully. It's complex. Onward.